Hey everyone, it's Matt here with Night Run Studio, and welcome to our first code refactor video. Throughout this series, we'll take time to do a little bit of code maintenance here and there, and this first time is going to be some pretty serious maintenance. In fact, this looks like it's going to be the longest video I've ever made for this channel. What we're going to be doing here, though, is something called introducing a finite state machine. And essentially, we're just going to be making a separate class for every state the player can be in, like idle, running, sliding, etc. What this does is it means that at any time, the player can only be in one specific state, and we're going to be pulling a lot of our logic out of our player script and into those state scripts. At first, this is going to seem like we're actually making more work for ourselves, but in the long term, it's going to make life really easy. You'll notice that our player script has already bloated to about 300 lines, and we're just getting started. Additionally, we've got complicated things like, say, in our handle animation, where in order to run, we need to be moving, holding run, not sliding, not crouching, and just imagine how many other nots we're going to have in there once we've got 12 or 13 states. Additionally, the switching between states is starting to get convoluted as well. So by doing this, we're just going to simplify our logic, we'll make bug fixing much easier, and it's also going to be way easier to add new states. So anyways, that's where we're headed in this video. Let's get started. Alright, so the first thing we're going to do is create something called a base state. I'm going to name this one player state, and we can open that up. And essentially, this is going to work like a blueprint for our other states. In fact, this one is not going to be a mono behavior, it won't live on an object in the scene, we'll be creating it while the game is running. And it's also going to be an abstract class, which means it won't have access to start and update, so we can get rid of those, and instead will function as a blueprint that will provide logic that each of our states can borrow. So let's go ahead and create our blueprint. First off, we're going to create all of the methods that our states are going to need. So for example, they're going to need to fire some code when we enter them. That's actually when they'll be playing their animations. For this, we're going to make a public virtual void called enter. While we're at it, let's make a virtual void exit method. And then for now, at least, there's just two more methods we want. One is going to be an update method. This is where we'll do all of our logic for switching states. And finally, a fixed update, which will be for our physics updates, so actually making the movement happen. Now, the next part might seem a little weird if you haven't worked with abstract classes before, but we'll be reusing this logic a lot in this video, and it should become clearer by the end. What we need to do now is create a constructor. So again, this isn't a mono behavior, so when it's created, we need it to run some logic. So the constructor is just a public player state, so the same name as the class itself, and it's going to take in a parameter. So when we create this, we're going to pass it along a copy of the player script so that it has access to everything in that script. Now we just want to make sure that we store that reference to the player so that each of our states has access to it. So we'll make a protected player reference called player. Now we just need to fill that variable, so whenever this is constructed, it will take that player reference that's being passed in and then fill its own reference to the player with that reference that was just passed into it. Okay, so I realize this has been pretty abstract so far, so let's actually get into making one of our states, and it should start to make more sense. So this first state is going to be our player idle state. Let's open that up. And here, this one is also not going to derive from mono behavior. This one is actually going to derive from our player state. This is called inheritance, so it will inherit all of the logic and references that are in that script, but it can also add its own, and it can override aspects of the parent. So let's start by overriding the enter method of our player state script. So first off, anytime we enter any of our states, we want to make sure that we play their animation. So let's tell our player that his animations should set the bool for is idle to true. Now at this point, we can head over to our handle animations, and you'll notice that we can actually get rid of that line altogether now. And instead of having to put that complicated set of statements in here checking, we can just set it to true when we enter the state. Now I want to set this up so that it's a little smoother. You'll notice that we have the player prefix here, and we're going to be using that a fair bit, but we can save ourselves some trouble by storing some of these variables, like the animator, in our base state. However, at the moment we haven't fully linked this state to the base state. It needs a constructor similar to what our player state did. And so as soon as we create this state, which we'll do when we start the game, we're going to feed it in some logic. So as with our player state, it's going to have a public player and then its own name comes after that. It's going to take in a reference to the player. And then the thing that's different here is that this one is also going to talk to its base state, the player state. And what will happen is when we instantiate this state, it's going to also tell the player state where the player is. So because we're passing the player reference to the base state, we don't need to store it in each of these individual states. Let's actually do the same thing with our animator. So the base state can have a reference to the animator, we'll call it anim, and then when we construct it, we're just going to tell it that this animator, or anim, is equal to the one that we're storing in our player. Now we don't have to refer to player before we can talk to the anim, we can just talk straight to the anim. Let's copy this method here and then create a exit version that will just set the animation to false. Great, now our animations are set up, so let's create the logic for how we transition out of this state. We'll do this in an override update method. You'll notice when mine autofilled, it added this base.update. What that means is that it will run any logic we put in the base state's update method before it runs its own. All right, so let's set things up so that we can jump from our idle state. So if our player dot is jump, well, we can't actually talk to is jumping. Let's head over to player. You'll notice that all of our checks for run pressed, jump pressed, move input are all private. Let's just set those to public right now so that our states can talk to them. So if our player registers the jump is pressed, well, the first thing we want to do is tell our player that it should no longer be pressed, as we don't want this to multi-fire. So we'll just say jump pressed equals false. So when the jump is pressed, we need to change states. However, we don't have any logic for that. Currently, we're handling that in a number of different places, and we want to make that a whole lot cleaner. So first of all, let's come into our player class, and up at the top, we're going to make a player state reference to our current state. Next, we just want to make a reference to all of the different states that we can go into. We've only created one so far, so let's make our first public player idle state, and we'll just call this one idle state. At this point, then we're storing a reference to our current state and to a player idle state, but those states don't actually exist yet. So let's head into our awake method. So before we even run start, what we want to do is create each of these states. Remember, they're not mono behaviors, so we have to create them at runtime. So our idle state is just going to be equal to a brand new player idle state, and then we're going to pass a reference to this script. Remember, each of these expects to get a reference to player passed into it. Now when the game starts, we want to tell our player to change his state to idle state, as that's where we're going to start out. Although as you can see, we don't have a change state method yet. So let's go ahead and create that. So whenever we call change state, it's going to want to take in a player state, which is going to be the new state that we want to go to. At this point then, we can just make sure that our current state gets exited, and this is what will cause it to run, its exit logic. We'll then set our new current state to be whatever new state was passed in. And finally, we can tell current state, which is now that new one, that it needs to run its enter logic. One last little note, when the game begins, we won't have a current state at the very first frame, so we just need to add a line of logic here so that if current state is not null, we exit it. Otherwise, it will try to exit a state that isn't initialized yet, and you'll get an error. All right, we've reached our first checkpoint. We removed the logic for setting idle true from player, so now if when we run the game and our player idles, we'll know that the idle state is working. That said, when I get in here, you'll notice I have an error. In my case, it's actually just because I forgot to save. We're going to be in and out of a lot of different scripts in this video, and so I recommend that you use file save all anytime you want to save, just so you don't forget to save a specific script. All right, and when we get in the game, my player's idling, so we know that at least this first part is working. He is entering the idle state. All right, so now in our idle state, let's actually head to a different state. So we're going to make it so that when we press jump, we actually change state and we go to the player jump state. Now, obviously, we've not created that yet, so we're getting an error. Let's pop back into Unity and just create a player jump state. We'll get this set up, and hopefully this pattern will become pretty familiar soon. We'll get rid of start and update, make sure this derives from player state, and then create our constructor. Remember, that's just a public, and then we put the name of this script. It's going to be expecting a player reference, and then we want to make sure that we pass that player reference along to the base state. Next, we can create the public override enter, and I'll just leave the base enter here. And here's where we want to tell our animator to set the bool is jumping to true. We can then copy that method, change it to exit, and make sure that it sets jumping to false when we leave. Now we're getting close to being ready to test this animation. However, if we go back to idle state, you'll notice it's still grumpy about the existence of a jump state. That's because we don't have a reference to it. So let's head over to our player, make sure that it gets a reference to the player jump state. We'll call it jump state. And then we'll also make sure that on awake, we create that. So jump state will be a new player jump state. And again, we'll pass along this script. Now that we've created all this logic, we can start to extract some lines from our player script. So we can get rid of the jump call in our handle animations. We can get rid of handle jump altogether, though I'm going to cut it rather than deleting here, as I'm just going to borrow some of the logic later. We can also get rid of the call to handle jump in fixed update. Now in our player jump state, I'm just going to paste that handle jump and comment it out, just because there's a couple lines here that I'm going to cannibalize in just a moment. All right, so as soon as we enter this state, we want to actually jump. So let's make our linear velocity equal to, and we'll generate a new vector 2. It'll be our current velocity on the x, and then for the y, we're just going to grab our player's jump force. At this point, I'll just borrow some logic from below, as we want to reset the jump pressed and jump released values to false at this point. Now at this point, I'm just going to do a little bit of a shortcut that will take a moment now but save us time in the long run. We don't want to have to type player.jumpPressed, player.jumpReleased every single time, so let's store these variables in our base state. I'm going to make a protected bool reference to jump pressed, though this time I'm going to give it a capital J. In code, that means we're making a property, which is kind of like a variable reference, but just gives us a little more control. And here, anytime we want to get its value, we're going to add a lambda expression here, which just tells it to look somewhere else. And so when we try to get the jump press value, it'll just look in player and get whatever its jump pressed variable is. We're also going to give the ability to set it though, so that whenever we try to set the jump pressed value from one of our states, it'll tell player to change its jump pressed to that value. We're then going to do the exact same thing for our jump released variable. Now in our jump script, we can just change it so that it's a capital J and the angry red lines will go away. I also want to head to our idle state right now and just make sure that we change it so that it's not referring all the way back to player. It can just talk directly to jump pressed in the base state. All right, now we want to create some logic for when to leave the jump state. So let's create our override update method. And here we'll do a check. So if player.isGrounded is true, so we're on the ground, and our rigid body's linear velocity on the y is less than 0, meaning we're moving downward, then we want to tell our player to change state to the player idle state. Now let's also add a little bit of physics logic, so we'll use a override fixed update here. We just want to make sure that we're telling player that it needs to apply variable gravity all the time that we're in this state. We can then get rid of that line from our player state. Additionally, you'll notice that the apply gravity method is currently just a void one. We want to make sure it's public so our state can read it. Next, we want to add our variable jump height based on whether we're holding the button. So let's check to see if jump is released and our current velocity on the y is greater than 0, meaning we're still going upward. If so, then we want our velocity to equal a new vector 2. And here I'll just copy that line from down below so that our x stays whatever the rigid body wants to do, and our y is now our velocity but multiplied by the jump cut multiplier. Now at this point also don't forget to make sure the jump released is false. We want to consume that so that it can be used again on our next jump. Next, we want to give ourselves some control over how fast we're moving left or right while we're in the air. So we're going to create a new float here, and this one's going to ask the question, well, is run pressed? Now we don't have access to that yet, so let's just add that into our base state. So like we've done for our jump ones, we'll make a bool for run pressed. However, here we're never going to need to set it, we just want to get the value, so we can just get it from our player. So if run is pressed, then we want to make sure that we make our speed equal to the player run speed. If not, it will be the player's walk speed. Now let's just apply that speed to our rigid body, so we'll make its linear velocity equal to, and here for the x, we'll just do speed times whatever direction the player's facing, and for the y, we'll just let our rigid body do its own thing on the y. Now that we're starting to use our update and fixed update methods in the states though, we need to actually call them, as by default, they're never going to run. What we want to do then is go back to our player script, which is the quarterback for all of this in the end, and we want to make sure that in its update state, it constantly tells the current state to run its update method. That way we don't have all of our states trying to run their updates all the time. It will just be the current state that does that. We can then do the exact same thing for fixed update. With that done, we can test, and don't be alarmed, things aren't going to be working perfectly just yet. We should be able to jump, though currently we have a hybrid where some of our logic for jumping is run in our state and some of it is still in our player, especially the animations. Additionally, we can't run at this point, and yeah, it's just not perfect. So let's go ahead and create our move state next. And to do that, we're going to start back in our idle state. At the moment, the only way out of our idle state is through jumping. So let's head down to update and add another option. We'll put an else if block in here, and we'll just check the absolute value of our player's move input on the x. If that absolute value is greater than a really small amount, like say 0.1, then that means we want to move into our move state. Now we're going to need to access our move input a lot in our state machine, and I'd prefer not to have to use the player prefix each time. So let's head to our player state and do something similar to what we've done for our run and jump pressed. This time though, it's going to be a protected vector 2 called move input. And this time also we don't need to set it within our code, so we can just add the getter. Now we can go back into idle and just remove the player prefix in front of our move input. And now the only squiggly line here is over our move state, which we need to create. So let's head into Unity and make a new C# script called player move state. Now hopefully some of this setup is starting to feel familiar by now. First of all, we'll remove the mono behavior and make sure we inherit from player state. We can get rid of start and update, and then we'll add a constructor using the same name as this script, taking in a reference to player, and also passing that player reference along to the base state. At this point, we can go ahead and create our override enter method. Now this state's a little different as we don't know for sure whether we want to play walking or running on enter, so we'll just leave that for the moment. We can then add our exit method, and we want to make sure that when we exit, we do set both walking and running to false. Now, as far as turning on our animations goes, we're going to do this in update, and it's always going to depend on whether or not we're holding down the run button. And so we can set the bool for walking to be the opposite of run pressed. So if run is pressed, walking should be false, and vice versa. We can then just copy that if we like, and for is running, we just want it to be the same as run pressed. Okay, now let's add our logic for changing states. So first of all, if jump is pressed, we want to tell our player to change state to the jump state. However, we also want to have the option to go back to idle, so we'll put an else if, and here if the absolute value of our move input on the X is incredibly small, so we'll just put less than 0.1f, then we want our player to change state back to idle. Now the other major piece of this is to actually get our player moving, so let's add our fixed update, and here we're going to start by setting a float for our speed, and this will just depend on whether or not run is pressed. If run is pressed, then we want to look in player and grab our run speed, and if not, we want to use the player's walk speed. At that point, we can just set our velocity to a new vector, which is going to be our speed multiplied by our player's facing direction. And then on the Y, we're just going to let our rigid body do its own thing. Hopefully at this point, it's starting to feel like it's actually getting easier when we add a new state on. That said, if we go back to our idle right now, you'll see that it's not totally happy with us. It still doesn't know what move state is, and that's because we need a reference in our player script. So let's head on over there. We'll start by creating a place to store our move state, and this will just be a public player move state. Then we'll come down to awake and actually create that when the game starts. So then we'll just tell it that our move state is going to be equal to a new player move state, and we'll pass along a reference to this script. And now that we've created that state, we can head down to fixed update and take away our call to handle movement, and we can get rid of the handle movement method altogether. We can also come down to our animations and get rid of our running and walking calls, as well as the one here that checks our is moving, as we don't need to do that, it's happening in the state. Now when we get in the game, we're partway there. We idle, we can walk and run. However, when I jump, here you may not be able to notice, but I'm not pushing a button and yet my player is continuing to walk. If I look in my animator, you can see that is walking and is idle are both true, so something's going wrong here with my transition. Now to fix this, we're just going to pop into our idle state and make a couple of changes. First of all, in enter, I like to make sure that right away when idling, we turn off our velocity so the player comes to a halt. So let's just make sure that our velocity is set to a new vector that has a 0 on the X, and the Y can do its own thing. Now the main problem, however, is happening in our move states update method. Now update runs every frame, and so every frame we are setting our walking and running bools, and so even on the frame that we are exiting this state, we're still evaluating and setting those bools, which is why they're getting set true, even though our exit is trying to turn them off. So let's just put this in an else statement, so that if we're going into our idle state, it won't run this block. All right, at the moment, things are mostly working. We can run and jump and idle and all of that. However, you'll notice occasionally I'm getting a strange hitch where my jump animation just doesn't want to end. There's a couple of things contributing to this, but if we go to our animator and click on our jumping, falling, and landing animations, we'll notice that I forgot to turn off loop time. If we make sure to do this, it will at least solve some of our problem. That said, don't be alarmed if some of the problem persists, as we will get to that later in the video. Now, I know this video is turning into a little bit of a marathon, but bear with us. I promise future refactor videos will not be this long. However, this is really important for our architecture. Next, we want to go ahead and create our crouch state. Again, we'll do the familiar things of making sure we inherit from player state, getting rid of start and update, and then creating our constructor. Next up, we can go ahead and add our override enter method, and then just make sure that our anim sets the bool for is crouching to true. We can then copy paste that, make sure his crouching goes to false, and then make sure that's on exit instead of enter. Next, we want to make sure that when we enter the state, our player changes his collider size. We have that method already in player, so we can just use player.setColliderSlide. However, we need to make sure that in our player, we set both the collider normal and collider slide methods to public so that our states have access to them. We can then make sure that on exiting crouch state, our collider goes back to normal. Next, let's get our physics working. So in fixed update, we want to make sure that our rigid body's linear velocity is held still while crouching. So I'll just create a new vector with a 0 on the x and let the y do its own thing. Now that said, we want to avoid a situation where we become soft locked if we're in a low space crouching and can't move out of it. So let's add a situation where if the absolute of our move input x is greater than 0.1, so we're pushing left or right, and in that case, let's allow our velocity to be set to our facing direction multiplied by, and here let's just use walk speed as it would seem silly to be running while crouching. Then we'll just let our rigid body do its own thing for the y. Then we'll just put this other velocity where we zero out the x in an else statement so that only if we're not pushing anything will his movement be halted. All right, let's create our transition logic now. So we'll add our update method. I want to be able to jump out of my crouch state, so if jump's pressed, I'll tell the player to change state to the jump state. We'll add an else if statement here, and let's create a situation where we can stand up by not pressing the button anymore. So if moveinput.y is greater than -0.1, so we're not holding it down, then, and actually later on we'll need to check for ceiling, but we don't have a way to do that yet, then we want to tell our player to change state to idle state. That said, let's go ahead and create that ability to check for a ceiling. If we head over to player, right now we have this quite long method called try_stand_up, which we're going to actually be getting rid of by creating a simple ceiling check. Here we're just going to borrow this overlap circle logic, and since we'll now be handling this through our state, we can get rid of the calls to try_stand_up in both handle slide and in update. Now I'm just going to come down below where we already check our groundedness, as that's a logical place to check for a ceiling. So we'll make a public void that does this, and then inside of this method we can just paste that overlap circle that we copied from try_stand_up. Now the one thing we want to do differently here though is that we actually want to return this so that when we call this method it will actually tell us if we are able to stand. So here we're going to make this a public bool, so it'll return a true or false value. Here we'll add a return in front, and so now if there is in fact ground over our head, it'll return a true value, there's a ceiling. If there's no ground over our head, it will return a false value. Now we can just add this condition into our crouch state so that if we are not pressing down and, don't forget the not here, there is no ceiling, then we can go to idle state. Now that we've created this crouch state, we need to actually transition to it from other states. Makes sense to be able to crouch from an idle state, so let's head there. And down at the bottom, we'll add a else if statement, which is just going to check if our move input for the y is less than a -0.1, so meaning we're pushing down. Now if that is the case, we want to tell our player to change state to the crouch state. Now at the moment, player doesn't have any way to keep track of that state, so let's head over there and make a public player crouch state called crouch state. And then when the game wakes up, we'll tell it to create a crouch state by making a new player crouch state and passing along a reference to the script. Don't forget to save all at this point as we've been in a few different scripts. Now when we get in the game, we can jump just fine, we can run and crouch and everything. However, you'll notice if I try to jump out of my crouch, we're getting a little bit of a forward velocity here. Now the reason for that forward velocity on the jump is happening in our jump state, and it's just because when we set our speed, we do it based on whether or not we're holding run. So we're always applying either a run or walk speed to our jump, even if we're not holding a button. So we're just gonna add one extra step. We'll make a float called target speed, which will take that speed of run or walk, but then multiply it by our move input. So if move input 0, it'll zero it out. We can then just make sure that we're using the target speed as our x value for our linear velocity. Now that fixes the forward velocity, but how about this problem of getting stuck in jump state? Well, really what's just going on is in update here, whenever we go to jump, we're checking if we're grounded and if our linear velocity is less than 0. But what if we're just standing on the ground? Then it runs into a problem as it's not really recognizing that we should go back to idle. So here we'll just add the equal so that if we're not going up or down while we're on the ground, we still go back to the idle state. All right, now things are looking much better for our jump and crouch and everything else. We just have to add back our slide state now. So let's go ahead and create a new script, and this one will be our player slide state. Now the crouch state is undoubtedly our most complicated state so far, and it's going to be nice to move out of having a bunch of disjointed logic in player and putting it all in one place. So let's get rid of our start and update, make sure we're inheriting from the player state, and then create our constructor. We'll create our override for enter and make sure that isSliding gets set to true. And then we'll come down, make a copy of that, and make sure that on exit we set isSliding to false. As with crouch, we want to make sure that we set our collider to slide when we enter and then back to normal on exiting, and here we're seeing the benefit of good code. We wrote these methods in one centralized place, and now we don't have to duplicate it in each state, we can just call it. Now, next you'll notice that we have a bunch of slide settings in our player state. We want to keep these public ones so that you can still see them in the inspector and set them, but now we can get rid of the slide input locked altogether. Our state will get rid of the need for it, and then our slide timer and stop timer we can cut out of here, and then we can go ahead and paste those into our slide state. So when we enter the state, we'll play the slide animation, we'll change our collider. Now we want to also initiate our timers. So let's make sure that the slide timer is set to be equal to whatever our player's slide duration is. And the stop timer we're actually going to put at 0. Next, let's set up the physics of our state. So we'll create our fixed update method. And here, let's first of all check to see if the slide timer is greater than 0, which means we're still in our slide. If that is the case, we'll give our linear velocity a steady speed, so the new vector will be comprised of our player's slide speed multiplied by his facing direction, and of course we'll let the y do its own thing. Next, we'll add an else statement, and this will just be when the slide runs out, and at this point we want to kind of bring him to a snappy halt rather than having him drift constantly afterwards. So here our linear velocity will just be a 0 on the x. Now if you like at this point, you can clean things up, because anytime an if or else statement only has a single line of logic, you actually don't need those brackets. And if you find that that keeps your code more readable and not so long, feel free to do it, though you can leave those brackets in there if you like them. Next, let's create our state transition, so we'll add our override update method. Here we want to make sure that if our slide timer is greater than 0, so we're still in the slide, we subtract the change in time from it so that the timer actually counts down. Now if our slide timer is run out, meaning we're done sliding, first we want to check to see if our slide stop timer, which governs that little pause at the end of our slide, is still running. So we'll check if it is less than or equal to 0. If that's the case, then that means it's not currently running, and we need to actually set it. So at this point, we'll set our slide stop timer to be whatever our slide stop duration is. Finally, if our slide stop timer is greater than 0, that means we're in that pause at the end, and so we want it to count down. And then if it at this point gets to 0 or less than 0, then we want to think about transitioning out. So we'll check if there's a ceiling above us, and if there is a ceiling, or if we are pressing downward, so our move input y is less than -1, that means we want to go into our crouch state. And if neither of those things are true, there's no ceiling above us or we're not pressing down, then we just want to go back to our idle state. Again, I'm going to remove these curly brackets just to keep my code a little more compact. Now we can really simplify some of the logic in player. First of all, in update, we can get rid of our call to handle slide, and then we can get rid of that entire monster method. Additionally, in our handle animations, we can get rid of our check for crouching, as well as our isSliding bool. We are going to leave the isGrounded and y velocity in here though, as those are things that all states are going to need to access at different times, and so it's good to have them in a nice central place. Now we just need to actually transition to the slide state from our other states. So let's head into the player move state. Here we can come down to update, and we'll prioritize a check for jumping, as well as our idle state when we're not pressing a button. However, if neither of those things is happening, if our player's on the ground, and we're pressing run, and our move input on the y is less than -1, meaning we're pressing down, then we're ready to go into our slide state. Now of course our script isn't happy with us, and that's because we need to set up our slide state in player. So first let's make a reference to the player slide state, we'll call it slide state, and then in awake we're just going to create a new slide state, and we'll pass along a reference to this script. Now I realize this has been a very long video just to add no actual functionality, but just clean up our code, and it might not even seem like we cleaned up our code, as there's now a lot more of it. That said, we now have a highly modular code that can easily be added. New states, just create a new script and make the transitions, and we won't be getting into spaghetti code situations with tons of bools and that sort of thing. Anyways, you'll notice that things are working pretty well now. We do have a no animation for our crouch walk state. That's unfortunately just the fact that we don't have one in this pack. That said, we're going to be adding lots more in the videos to come. Our next video, we're going to start getting into attack and damage states. Hope to see you there. Until then, this is Matt with Night Run Studio. Cheers.